Suppose I want to evaluate this integral, x minus 6 quantity to the 3/2 power. And suppose I want to do it by the guess and check method. What you have to remember is guess and check involves guessing the antiderivative, the integral, then checking your guess. If it matches exactly, then your guess is the answer. If it's off by a constant factor, just a numerical value, you can adjust that in your guess, we'll call that the adjusted guess, by using the reciprocal of what you're off by. Then check that solution by taking its derivative, making sure it matches the original integrand. If it does, then that's the answer. If you cannot get a match within a constant, just a numerical value, then guess and check doesn't work. In general, we're going to be using guess and check on the easier of these problems in any case. So you always have other choices. We're going to be, generally speaking here, using the general power rule for integration as our model for our guess. And the reason is, when you have an integrand raised to a power, the general power rule for integration tells you that the solution will have a power 1 higher than the power in the integrand. So when I'm doing this problem, I'm going to guess, let me just copy it back down here for easier viewing. I'm going to guess that this solution will look like x minus 6 to the 1 higher power than 3/2. Now I hope you don't have to think too much about this. Remember, when you're adding 1 to a fraction, in this case 3/2, 1 is like 2/2, so you end up with an exponent of 5/2. So my guess will be 1 higher exponent than the original. 3/2 plus 1 is 5/2. Now I have to check that guess. How do I do that? I take the derivative of the guess. You should be good at derivatives by now. That would be 5/2 times the base to the 1 less power, just working backwards from the calculation we did a minute ago. 1 less than 5/2 is 3/2, and then the derivative of the inside is 1. So you end up with 5/2 times the quantity x minus 6 to the 3/2 as my check. So does it match exactly? And the answer is not quite. You have the x minus 6 quantity to 3/2, but you don't have a 5/2 in the integrand. There is no 5/2 there. So you didn't get an exact match. What do you do when you don't get an exact match? Well, you make an adjusted guess. Your adjusted guess will take into consideration what you are off by. You are off by a factor of 5/2. Generally speaking, you will adjust by the reciprocal of what you are off by, factor-wise. The reciprocal of 5/2 is 2/5. So my adjusted guess is going to be 2/5 of what I originally guessed, which was the quantity x minus 6 to the 5/2. And then I have to check that guess. Checking the adjusted guess, I again take the derivative of the adjusted guess. By the power rule, you take the exponent times the coefficient. That's 5/2 times 2/5. Write the base down, x minus 6, and reduce the power by 1. As we've discussed, 5/2 minus 1 is 3/2, and then the derivative of the inside is just 1. Notice that 5/2 times 2/5, in other words, a number times its reciprocal is always 1. So you end up with just the quantity x minus 6 raised to the 3/2 power. So that's your adjusted guess. Does it match the original problem? Well, look. The original integrand and our adjusted guess's derivative are, in fact, an exact match. Exactly. That means my adjusted guess was right. What was my adjusted guess? My adjusted guess was this 2/5 quantity x minus 6 raised to the 5/2. If it's exactly right, then that is the answer. So the answer is the quantity x minus 6 raised to the 5/2 power. And don't forget, as always, you still have to put a plus c, because thinking backwards, the derivative of any number is 0, so there could be any constant added onto the end. And there is the answer by guess and check.